I'm Mr. Marco Justin Msigwa from University of Dar es Salaam, Mkwawa University College of Education. I'm a teacher of mathematics and informatics with my colleges.
I'm Felician BTK Mapunda. I'm taking mathematics and economics.
Godfrey Fred. I'm teacher for mathematics and informatics.
On behalf of my fellow teachers, we are going to talk about the applications on a real life situations on a weak and a strong convergence in a non-vector spaces. How is it applied in our daily life? By starting with the weak convergence non-vector spaces, as by definitions we say, provide that you are given a sequence xn in a non-vector space x, and with a certain point x, which is an element of x, the sequence xn is said to be convergent weakly to a point x if the function of f of xn is approaching to the f of x, as the value of n contains for every values of f on that sequence. In this concept, it is very applicable in your life, since for anything that we are looking for our daily our normal activities, we should compare that to the. So in a real life expression, consider on the signal compression, where the weak convergence is applied, especially on a video recording, audio recording, but also on sounding waves. Consider there is original signal, as you see here. These original signals that will be recorded by audio devices, and the compressed one, the one which will be mixed, and there is slight changes that are made. So the result here that we expect to ensure that there is a convergence which is very weak, the compressed signal should be looking the same with the original signal, but in reality there is a difference, because these original signals, it contain a huge amount of details, but the compressed one, there must be a slight change that are made, even though cannot be detected by the human ear. So in general, we say that this signal compression in a weak convergence, especially in non-vector spaces, we expect that the two different objects should be looking the same, even though in logical there is a slight difference. Another part is a strong convergence in a non-vector space. These strong non-vector spaces, mathematically we say, consider you have a sequence xn which is strongly converges to x. For this statement to be true, the limit of those values of xn minus the values of x should be equal to 0 as n approaching to infinity. It means that there are differences values. This xn it contains many values which are known, but all these values should be strongly converged to a value of x, and the result of the limit that you obtain as n approaching to infinity should be approximately equal to 0. So the real life application of this strong convergence, it is in a precision medical imaging, which is MRI, where here we're looking for the patients who visit for the checkup, especially for cancer detection. It can happen that there is two different patients who visit at different time. So the first patient maybe if he or she visited to the hospital for checkup, and he observed that after taking the MRI measurement, the result can be maybe has been seen that is suffered from cancer detection. The same after a time, another patient come for checkup also, the result could be same the same or difference. But in the concept of strong convergence in a non-vector space, what you expect here for two different objects should be matched exactly. There should be no any difference. So if the patient who visits the hospital for checkup, those two patients should be the same, should have the same signs after the measurement has been taken. So the convergence of the approximations to the true images of both patients should match for 100%. Thank you so much for your attention.